So today we want to talk about factor labeling and what that means to measurement. We're going to begin with the metric progression again. Here we have the metric system, which is all multiples of 10. So a milli, centi, deci are prefixes that go to these standards and many others: meters, liters, grams, seconds, Kelvin temperature, and many other things. Then deca, hecto, kilo. So you could say kilometer, kiloliter, kilograms, all the same thing. Each of these here is one multiple of 10 apart. So it makes it very nice to work with in terms of using decimals. We'll talk about that in a minute. Then you'll notice there's a squiggly line, and it goes up to mega. That's 1,000 different. And then it jumps again 1,000 to giga, and it jumps 1,000 to tera. These are the big things. Down here we go small. We have the decigram, the decimeter, and then the centiliter, or a millimeter, milliliter, okay? And then you jump to 1/1,000,000th, which is a micrometer, microgram. A nanogram, or a nanometer, so our phones are in nanotechnology. 10 to the minus 9th, or 1/1000,000th. And then 1/1000,000th, 10 to the minus 12 is a pico something, okay? So there's our metric progression, and we need to be able to go in between them. Okay? And for instance, if we have a meter and we want to change it to a hectometer, how do we do that? If we have a centimeter and we want to change it to a kilometer, how do we do that? And vice versa. If we have a decaliter and we want to go down to a milliliter, how do we switch those units? Well, that's a basic form of what's called factor labeling. And let's go with something maybe that you would recognize. If we use money, okay, in order to factor label, we need an equality. For instance, if I have 10 dimes, I think most of us would agree that that would equal $1. Okay, that is an equality, and that's how I start working with factor labeling. Okay, from this, I can establish what are called conversion factors, because I'm going to change one unit to another unit eventually. So in this case, I want to change dimes to dollars or dollars to dimes. What kind of conversion factor? It's simply setting up an equality like this. I can take the 10 dimes and I can divide by $1. Or I can take $1 and I can divide it by 10 dimes. This is a conversion factor. There's two of them here. The reason I can do that is because both of these things equal 1. So when mathematically I use them, I can multiply by 1 or I can divide by 1 to get the number I start with. For instance, let's say I have $2 and I want to know how many dimes that is. So I go to my equality. I know that 10 dimes is $1. I also know that I have these conversion factors I can work with. Now, which one will I use? Well, I have dollars, so I want to get rid of dollars. Mathematically, to get rid of dollars, since it's in the numerator, I'm going to divide by dollars. So I want this conversion factor. I have $1 in the bottom, and I have 10 dimes on top. Okay? So you can see here that now dollars will cancel. And 2 times 10 would give me 20 dimes. Let's switch it around. Let's say that I have 35 dimes. Okay, 35 dimes. Again, I have an equality. I know that 10 dimes is $1. Okay? I need a conversion factor that I can use to get rid of dimes and end up with dollars. So dimes is on top, so I need dimes on the bottom now. 10 dimes is on the bottom, and on the top then goes the $1. See, I need both because this equals 1. So I can multiply this by 1, and I still get the same value, although I'm changing units. So now you can see that dimes cancels out, and I'm going to end up with $3.50, okay? Or 35 divided by 10. And it makes sense. That's factor labeling.